solve x minus 4x to the 1/2 minus 21 equals 0. Now, the easiest way to solve this equation is to recognize it's in quadratic form because this middle term, x to the 1/2, if we squared x to the 1/2, we would get x to the 1, in other words, just x. And so what we can do is let u, a new variable, equal to x to the 1/2. If we sub that in, so let's write this equation in terms of u, we would get u squared, right? Because x to the 1/2 squared is x, and so that's u squared, minus 4u minus 21 equals 0. And we can factor this quadratic equation, u minus 7 times u plus 3. Then sub back in u equals x to the 1/2. And so we have x to the 1/2 minus 7, x to the 1/2 plus 3. Then in each of these factors, we set them equal to 0. So on this side, we have add 7 to both sides, x to the 1/2 equals 7, square both sides, and we get x equals 7 squared, or 49. On the right here, we subtract 3 from both sides, then square both sides, and we get x equals 9. And these are our two solutions, but we're not done because we squared both sides of the equation to find these solutions. And so we need to check our answer, because when we square both sides, we could possibly end up with extraneous roots that are not actual solutions to our equation. So if you plug 49 and you plug 9 back into our original equation, so if I plug in 49 here, do some arithmetic, you'll see that it's actually equal to 0. However, if you plug in 9, you're going to see that for x, you're going to see that this left side is not equal to 0, and so 9 is actually not a solution to this original equation. Another way to think about it is that we have x to the 1/2 equals negative 3. And so that means the square root of a number is equal to negative 3. And if you think about it, you can't take the square root of a number and equal a negative number, because the square root has to be positive. We have to plug in, in other words, if you plugged in 9 here, you would get positive 3, not negative 3. And so the only real solution is 49.